Hi, everybody. Today we are going to be talking about exponents, and this is the page that we're on. So it says, in an expression like b to the a, b is called the base, and a is called the exponent. An exponent is shorthand for repeated multiplication. For example, the expression n to the fourth is equivalent to n times n times n times n. So we have worked with exponents before, and we've talked a lot about them. So this is just giving it a definition in words. So what we're going to be doing is we are going to be expanding each expression below. So for example, to expand x to the third, you would write it x times x times x. So if we're going to expand y to the seventh, how many y's are we going to write? We're going to write 7 of them. 1, 2, 3, 4, 5, 6, 7. So that's expanded out. Now letter B, does this 5 have an exponent? No, so I just write the 5 times the 2 to the m is the one with the exponent. That's written 3 times. So I'm going to write 2 to the m, 2 to the m, excuse me, not 2 to the m, 2m, 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 2m. I wrote the 2m 3 times because it was raised to the third. In letter C, what is raised to the second power? X to the third is raised to the second power. So that's what I'm going to be writing twice, is x to the third. And then here, I actually have 2 things of exponents. And I apologize. I'm actually going to go back up to this one. I still have exponents to take care of. I need to rewrite those x times x times x, and then x times x times x again, because it wanted to expand it all the way out. So this one, this step, I expanded out for that too. Then this step, I expanded out for those 3's. Okay, now moving on to D. 4 does not have an exponent, so I'm just going to write 4. And then how many times am I going to write x? 5. 1, 2, 3, 4, 5. And how many times am I going to write y? 2. Y times y. So that's it, expanded all the way out. The reason that it is important to know how to expand it out is because when we move down to number 65, expanding out the problem is going to be very helpful. Now, in these problems, it's talking about this problem over here, and this is a little bit complicated. So I'm just going to move right down to here. Essentially, it is saying that it wants you to expand out and then use a giant 1, which I call a magic 1, to write an equivalent expression in simpler form. So we're just trying to simplify the expressions. Now, what is a giant 1 or a magic 1? Now I'm going to zoom all the way in so you can see what's going on right here. Okay. Now, if I wrote 3 over 3, what is 3 over 3? 3 over 3 is 1. Okay, so what is 5 over 5? 5 over 5 is 1 as well. So right here I have x over x. If 3 over 3 is 1 and 5 over 5 is 1, what does x over x have to be? X over x has to be 1 as well. So right there, I just have a magic 1. And instead of writing those x's, I'm just going to write 1, and then what I have left over, which is x times x. And then what is 1 times x times x? That's written as x squared. So that's where expanding out helps. Now, obviously, these we did not have to expand out, but in the next one we will. And that helps you rewrite things. So let's do II. The first thing we're going to do is expand it out. So in the numerator, the top, I have this x to the 5th, so I'm going to expand that out. X, 2, 3, 4, 5, and I still have that y. And then in the denominator, I have x squared, which means I have x times x. Now, you have to find those magic 1s. So I'm going to circle anything that could be a magic 1. right there is x over x. That could be a magic 1. And this x over x is also a magic 1. So let's rewrite what we have. We have a magic 1 times a magic 1 times x times x times x times y. And then let's go ahead and rewrite that using exponents. Well, we don't need to write 1 times 1 because 1 times 1 is just 1. So we have x cubed times y. Okay. Now I'm going to have you do the next two and enter in your answers and see how you do. All right. So the first thing I'm going to do is expand out the numerator. K, 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 and then I have 5 more. 1, 2, 3, 4, 5. And then in the denominator, there's K times K. So let's go ahead and find those magic ones. K over K is a magic 1. K over K is a magic 1. So I have 1 times 1 times, and then I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that is written as just K to the 6. And then on IV, I have 16. Z times Z times Z over 8 Z times Z. So let's find our magic ones. Z over Z, that's a magic 1. Z over Z, that's a magic 1. Now, when you get to these types of problems with numbers, don't get scared. You know how to do this. If I covered this up and I just said, what is 16 over 8? You would know that. But when I add in all that other stuff, you get kind of confused. So don't get confused when it's like that. 16 over 8. 16 over 8 is just 2. And then I have a magic 1 times a magic 1 times Z. Well, the magic ones I don't need to write, so this is just 2Z. Okay. All right, next page. Number 66. Number 66 is a very common integrated 1-ish problem. And I said integrated 1-ish because it's a problem that looks really weird, and it has a lot of writing, and there's question marks. And when kids get to problems like this, they just are like, no, I'm not going to try that. That's too hard. You are capable of doing this just based off of what we just did. All it's asking is that true? Is that true? Is that true? So what you can do, cover up that right side, actually do this problem, simplify it like we just did. Take your hand away and see if it's right. If it's not right, then you know that it doesn't equal it. So let's do the first one, and then I'm going to let you do the other one. So I'm going to cover this up, and I'm going to say, okay, I'm going to expand these out. H, 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 1, 2, 3, 4, and then I have a K. Oh, cover it up. I don't want to see it. So I have 1, 2, 3, 4, 5, 6, 7 H. So H to the 7th times K. Now, is that what that says? No. So I would say they are not equivalent. That's all you're doing, is seeing if they're equivalent, and you know how to do those. So I'm going to challenge you to do those on your own. All right, go ahead and try to do those. And then your homework is very similar to all of those problems. It's just expanding things out, rewriting, and solving some equations. So I know that you're able to do that. All right, thanks for watching.